Hi. Okay, so I have been on a long excursion investigating related concepts to the levitator. So I have been doing like two-wing. Disappointing. There's a... Jag vill hoppas på lite mer kanske. Three-wing unsupported with just one single spar. This design really deserves a video in itself. It is sort of promising design. It's very quiet because it has proper airfoils with a proper surface and no wires out in the air. But it is also kind of flimsy. To make it lightweight, I needed to have the batteries inside the wings, so to distribute the load, so that the long wing spars didn't have to carry a heavy battery in the center, having the lift produced far away from that mass. So it was kind of sluggish since it has so much inertia. So it's more difficult for the flight controller to maintain the attitude, but perhaps again, like with better blown flaps or something, it might have been worth redoing. I did crash it for unknown reasons, so that's why I haven't made any more videos of this, because it's kind of a promising design, but the propellers are close to the ground since it has such a low undercarriage, but that saves weight on the other hand, so perhaps I will give it another go another time. And I tried to do a centrifugal version of the levitator as well. Släpper upp, släpper upp, släpper upp, släpper upp, släpper upp, släpper upp, släpper upp. Just det. Nu är jag helt uppsläppt. Nice. Ganska annorlunda yttre utseende om jag byter till en annan motor som inte går in där. I do like the concept, but I just can't make it work. And finally, I did the counter-rotating version. I tried to make a counter-rotating coaxial version of the levitator. And it turned out quite hilarious and disastrous. It was way under structured. It was too weak in every aspect. I tried to make it as light as possible with a kind of medium strength aluminum, but it just didn't work out. I would have need to overbuild it significantly from the current state, so it would have been too heavy. So I would have to utilize lighter material, more expensive materials, and I don't want to do that. So of course, after that session, I really wanted to go back to the original simplicity of the levitator concept. So one very simple, simplistic wing, put in a 3-wing array, of course, the rotary design. So it's really just one continuous swept curve that is separated at a certain distance that gives the washout of the wing. So that's the basic geometry, and then of course I have to make it more structural sound, and this time I gave it sort of a circular airfoil design. I know it's more efficient to have the thickness farther forward, but it's more difficult to maintain that shape. You have to have more spars, but the circular airfoil is so simple, and it does compete at certain angles of attack with a more conventional airfoil, but it's much more sensitive to angle of attack. So it's suboptimal, but from a construction standpoint, it's really super simple and very easy to cover as well. So I really did want to go back to this design, but it had its shortcomings, especially when it comes to moving faster through the air and still maintaining the slow, efficient rotary speed. But one thing I didn't try out in the in the original levitator was to have a configuration where the motor was not out here, but rather somewhere along the wing, and have a blown flaps configuration. So basically the airflow from the propeller is blown onto the control surface, sort of a flap, which will give it a certain amount of control authority even in the at the retreating blade that will stall first when it moves into the air. So you will still have a certain amount of lift produced even though the wing is in still air when it's moving forward. So I wanted to try that and see if that can broaden the flight envelope of this kind of slow rotary wing machine. So after the slight incident with the coaxial levitator, I made a quick rebuild, and thankfully most of the components were still okay. I did lose 2 motors, but all the batteries and servos and other stuff was just good to go, and also a lot of the aluminum itself and the battery holders, I just needed to shorten them down a little bit. So 3 of the 6 was reused in this blown flaps levitator design. So here we are again, same place but another season. So it's minus a couple of degrees, but I charged the batteries beforehand, so they should be okay to use here. Mandatory flag there for telling the direction of flight. I also have the same weather protection on this one. It's just shortened down a little bit. And the takeoff weight is 52.5 kilograms in this current state. And the landing gear itself weighs 7 kilograms, but I think I can lose most of that weight later on when I try out other ways of getting this puppy off the ground. And here you can see the motor, and it has a simple weather protection, simply in the form of being further in under the wing, and some really big servos that I'm trying out here as well, and just a plastic bag wrapped around the circuit board there for like basic protection. And there are more wires on this than the original one, and that's simply to support the significantly added weight. The original one weighed 12 kilos at takeoff, and this is like over 4 times that. And you can see a little bit here of the circular arc-shaped wing foil, airfoil. So it's only like 4% out there, but in there I think it's like 6 or 8 or something like that. Okay, yeah. So in order to do this build, I needed to make some rigs for building the wings. So that was sort of a major part of the build, to make that jig. And otherwise the the build itself was quite simple. All I really needed to think about was to use materials that could be just permanently stored outdoors, because this is too big to take in and out for every flight test. And I did have to come up with some ideas to measure the tension in the wires and stuff like that. But it's just all ordinary good engineering challenges. And now we are approaching the first test of the control surfaces. And I'm using two flight controllers. My flight controllers have 8 outputs, and this is set up as a octocopter, so there are 8 sectors for the control surfaces to pass by each revolution, adjusting the setting for each setting, setting for each sector. I mean, so that this one flight controller is operating the cyclic pitch, so to speak, and then there's one separate flight controller controlling the yaw, so keeping the base tube there at a fixed position so that it doesn't spin with the wings. And this setup seems to work quite nice. It doesn't work nice at all in low speed, so now I'm just turning the wing by hand like this. It will be very jerky. You can see it like overcompensates and undercompensates. But once it's up to like more than half flight speed, it starts to be a consistent counter rotation on the center part there, so it's basically just standing still and the wing is rotating. And it turns out I was super lucky here, so all the values had the correct like positive negative settings, so the control surfaces are actually doing the right stuff at in the right sector, so it's going to turn left, right and pitch correctly, but I don't know that yet, so I'm just checking and double checking, because if you get this wrong you'll just crash it immediately. And I have significant control surface movement there that you can see. So this I'm using the original settings from the first levitator, but I did, after thinking about it, I did alter the P gains for the cyclic there from 150 to down to 100, since this is a blown control surface configuration. I should have much more control authority from the start. So I was afraid to get like too much, it would be like over controlling the craft, so I did turn it down to 100 for the first test. Otherwise I tried to use previously gained knowledge, but since I of course always do modifications in each iteration, it won't like match perfectly. And also, I mean, there are so many, although this looks like the first levitator, it's actually a lot of new things going on, even like except the blown flaps. Just the servos themselves, they are these huge, very low-cost Chinese strong servos. I think they are like, oh, what is it? It's like 300 and something kilograms of force per centimeter. But these are the rather fast ones, so they are down to I think 0.12 seconds for 60-degree movement. There are servos that are even stronger, but they are like in the half-second range for 60 degrees movement, which will not work, I think. The lag will be too much. Even if I just spin the rotor there 1 revolution per second, I think it will be difficult for those servos to keep up. But they turned out to do the job, so that's good. They are way over like powered for this relatively small machine, but I did want to try the hardware that if everything would work out like perfectly, they would go into a bigger machine, and probably several ones of them for each wing. But I did want to try out that actual hardware, so that's why I have these oversized servos on this machine. And the motors there with their extended shaft was also a like reality check thing. I did need to somehow weather protect the motors. I don't want to have to cover them up after each flight, so tucking them in there under the wing seems like a very simple, efficient way to like reduce like 90% of outdoor weather conditioning, shielding them from like 90% of the outdoor weather conditioning without making any like separate parts to shield them. And the servo comes without a proper like box for the electronics, so I put just plastic bags temporarily before I do something more streamlined to protect them from the whatever comes from the propeller, because they are mounted in line, so whatever goes through the propeller will hit the servo and the circuit board. Unfortunately, I cannot just put the circuit board in epoxy, because there are several potentiometers and switches and stuff on the circuit board which you might want to adjust later on. So I do need some sort of cover that I can remove later on for further adjustments. Okay, so now I'm going to mount the propellers on the motors and start doing some spinning up tests. And now the propellers are mounted on the motor shafts, and it's time to spin it up and again try to just gently manipulate the sticks to verify that the movement of the craft corresponds to the direction of the sticks. It will be a little bit off because I'm not spinning it at flight speed, so the phase lag and gyroscopic precession is not what it will be when it's flying, but you still will get a hint just to make sure that nothing is reversed or way off. So I'm keeping a close look here at the wooden landing gear there, and just watch the movements and see that they correspond to my stick inputs. And it's just so vital for your like self-confidence to do this, because you could crash this machine so fast if something is not set up correctly. And now it's actually time to make the first little hop to see how it behaves. And I do have very well in mind just a couple of months ago when I did this with the coaxial machine, and how mind-bogglingly bad that went, and how uncontrollable that machine felt as soon as it left the ground. So it is just such a relief to see that it doesn't veer off and it doesn't behave unpredictable. So obviously not going to fly a lot, I just want to get it off the ground, and it actually managed to pull up. It's 52.5 kilogram, that's well on over 100 pounds with these 3 drone motors, so that's quite good. Although it does run almost on full power here, and it turns out that the motors are under prop, so I can use a little bit bigger propeller. They're pulling 40 amps in this ground effect hover, and the motors can take 60 amps, so I have some margin there to put on some bigger propellers, which also might help with efficiency. So yeah, it's really a big relief to see that it works. It really does work this time over. And I did notice that I do need to reduce the P gain even further. I went from 150 to 100 compared to the original version, but I need to go down more, and that's a very good sign, because that means that I do have significantly higher control forces applied to the machine. So that opens up for the possibility for this machine to have better, broader flight envelope and better flight characteristics, since I can reduce the gain and still have good control of the machine. So the rudders don't have to work that hard, or the servos don't have to deflect the rudders as much as in the previous version. So that's hopeful. And just as usual during these test sessions, things happen just on it like a string of pearls, one thing after another. And I mean, of course, that's what tests are for, to like check out all the bad designs and just make them better. So here I didn't manage to get off the ground. I'm not super surprised because I was really having a hard time getting it up in the previous clip as well, but this time it didn't leave the ground, and I thought that the batteries would be a little bit hotter now and probably better to deliver like the power to the motors. So it took a little bit of head scratching, but it was one of those silly things. So my propeller mounts are not ideal with the extended shaft. I don't have a proper seat for the propeller. So one of the propellers had come slightly loose, and yeah, well, it's just a stupid thing. I didn't. One of the motor shafts was too long, so the propeller bolt couldn't apply enough pressure on the propeller. So I just added a 3D printed part in all haste because it's like -degrees outside, so it's difficult to work with the machine. And that 3D printed part started to slip, and the friction made it heat up, and it just lost its shape. So yeah, let's have a look at that. So now it's time for the next test here, and I have reduced the sensitivity from the sticks. So I've adjusted the stick scaling value so that I don't over control the machine after fixing the propeller issue there, of course. And now it's time to try to gently move the craft around a little bit and see how that feels. And I have to say that the machine makes more noise than I would like it to, but it was a known thing that if I blow the air over the wings and the control surfaces, there will be a lot more sound than if they were mounted on the tips, just heading into undisturbed air and leaving just the jet stream behind. So it's a price that I had to pay to get this higher control authority. But it's really rattling quite a lot. I think it might be the control surfaces. There's a significant amount of slop in the linkage and in the gearbox in the servo itself. So I can reduce a bit of it because the linkage I can fix, but the gearbox is what it is. But this is the actual first a little bit of flight movement here, so I'm just so slightly broadening the flight envelope here. And it felt a little bit better, but I want to make new tests here and adjust the gain. I want to take down the gains more because it still feels not intuitive to fly it yet. And here I am in the middle of the next tests of the settings, the flight control settings, and something happens to the machine. Yep, right about there. It wiggles and it feels less connected to the stick and sort of sensitive. But I just thought it was hit by its own turbulence or something. But after a while I realized that this is not right. So I tried to set it down gently and just sort of reflect and think about what that could be. So I'm just staring right ahead of me, and then I suddenly catch it. It's something hanging from one of the wings that's not supposed to be hanging under there. So if you take a close look here, you can see that it's the control linkage there passing by, hanging down from one of the wings. So one of the control surfaces just got disconnected from the servo. And this is what is so beautiful with this machine. It's very fault tolerant, and I mean, it's a significant thing to lose a control surface. This is how it's supposed to look. And here comes the faulty one. So it was just a grub screw that came loose. I don't know if I did not lock tight that one. Should have done that, of course. I think I have on the other ones, but still, the screw is still there, but it's starting to slip. Well, yeah, that's why testing is, interesting. And I'm still in the process here of turning down the gains, which really is a very good sign. The machine does need less control surface correction to maintain its attitude, so it's really good and really hopeful. And I'm just trying to find a setting that feels intuitive and solid, and I'm certainly not there yet, but it's getting a little bit better. And as I have the opportunity and confidence to move it around more, it becomes obvious that I need to adjust the setting of the swash plate there. It's 67.5 degree. It just happens to be convenient preset. So the phase lag compensation is 67.5 degrees, and I want to bump it up to perhaps 75 or so, because this is just when I try to like go to or fly forward, it's going forward left, so it's a little bit too the action is too late. And yeah, same thing if I'm going right, it goes right but also forward, and if I go left, it goes left but a little bit backwards. And this is, this is a counter-rotating structure, so that means that it doesn't do the correct input in time. It needs a little bit more preset. And it's pretty easy to fix, but I haven't done that yet because I'm still just in the process of, at the same time, adjusting the basic gains. And it's only now that I really noticed that it doesn't really correspond to the stick movement. So that opens up for the risk of having sort of toilet bowl effect, or yeah, when you're compensating in the slightly wrong direction, which might make things worse. So that's on the list to do in the coming flight test, but I will have to recharge the batteries in between. And since it's negative degrees, I will have to wait for a little bit warmer weather because the batteries are solidly mounted in there. It's a lot of batteries, so it's just a part of the structure. But I can see that it's coming in better weather here in a couple of days, so I can put out the charger there and hook it up. And I have a lot of new tests I want to do. And also I will have to change the propellers to get more power out of this machine, because now it's limited to just a close to ground hover, which is of course completely like unsatisfactory. But there are a lot of interesting things that I hope to do here later on. Okay, so this is all for now, and I will hopefully have an interesting part 2 coming up eventually, but it might take a little bit of time. It depends on the weather and other projects. Okay, see you. Bye.